Hi friends, here is a nice problem. JEE Advanced 2017. We are given this function x cos pi times x plus greatest integer function of x. Right. Now, where is this function continuous or discontinuous? That is the question. Okay. So, there is this greatest integer function of x, right? So, that means it can break at any integer. This part will break at any integer. Okay. Otherwise, cos generally the cos function is generally continuous, right? That's the greatest integer function. So let's try to break and see. And in the options also we are given it 0, 1, -1, 2, whatever. So let's see at integers. Okay. When like when x is between 0 and 1, what happens to this function? When x is between closed interval 0 and open interval 1, this greatest integer function of x, this becomes this becomes 0, right? It is between 0 and this becomes 0. So the function will become x cos pi x plus 0 pi x. When it is between x is between 1 and 2, this part will become 1. So x cos pi x plus 1. When it is between 2 and 3, this part will become 2. So pi x plus 2. Similarly, pi x plus 3, pi x plus 4, whatever. So this is this set of functions between 0, 1, 1, 2, 2, 3, 3, 4. Now we want to verify what happens to this function at 0, at 1, at 2, at 3. Whether when we approach from the left, from the right, are we getting the same values or not? Right, that is what it is about, right? Discontinuous means from the left, from the right, you should get the same limit. At the same time, value of the function should also be the same. Here, right side, when you are approaching, obviously the value of the function limit are same. Left side also, let's check. For example, when approaching from the left of 0, that is -1 to 0, this function, right? This becomes what? Left of 0 if you approach, and then 0 times cos of something. 0 times cos of something, this is actually equal to 0. Right of 0 if I are approaching, then this x is 0, and 0 times something, that is actually equal to 0. So at 0, it is continuous. What happens when you are approaching at 1? From the left side you are approaching, then becomes 1 cos pi. 1 cos pi. Cos pi is -1, right? If you are approaching from the right side, it becomes 1 cos x plus 1, 1 plus 1, 1 cos 2 pi. Cos 2 pi is 1, so when you're approaching from the right, it is plus 1. Approaching from the left, it is -1. So it is discontinuous at 1. At 0, it is continuous, discontinuous at 1. What about 2? Approaching from the left. What we get? 2 cos pi into 2 plus 1, 3. 2 cos 3 pi. 3 pi is cos 3 pi is -1. 2 times -1 is -2. Right. And if you're approaching from the right of 3, right, that becomes 3 cos 3 approaching sorry, we are talking about approaching 2, right? Approaching 2 from the right. That is 2 cos pi into 4. 2 cos 4 pi. 2 cos 4 pi is also equal to cos 2 pi cos 0. So it is 1. That is 2 times 1. That is 2. So when approaching 2 from the left hand side, you are getting -2. 2 from the right hand side, you are getting +2. So it is discontinuous at 2 also. Okay. So it is continuous at 0, discontinuous at 2, discontinuous at 1. Similarly, we can say it is discontinuous at -1 also. Okay. Now, this is algebraic way of looking at things. Now, if we want to look at how this graph also behaves, that would be interesting. Right. First, let us understand, without these x's, the graphs of cos pi x plus pi times x plus 1, cos pi x plus 2, cos pi x plus 3, like this. Okay, cos pi x, let us understand this graph of this. Cos x, if it is cos x, what is the period? Period is 2 pi. If it is 2x, what is the period? 2 pi by 2, which is pi. Right. What about if it is pi x? It is 2 pi by pi, which is equal to 2. The period is 2. That means this graph will repeat itself after every 2 units. The regular graph is the cos 1, that will repeat itself after every 2 pi units. 2 pi is roughly 6.2 something, right? This green graph will repeat itself one cycle for 2 pi units. But whereas this red one is cos pi x. That means it is repeating itself after every 2 units. So that's why this red one is repeating that one cycle is from here to here, 0 to 2. Second cycle is from 2 to 4. Third cycle is from 4 to 6, likewise. So it is repeating in every 2 units. So period is actually 2. Period is 2. Right, what does that mean? cos pi x period is 2, then x plus 2, pi times x plus 2, x plus 4, x plus 6, x plus 8, x plus 10. All these graphs are same. Because what is period? Period means after every 2 units, when x is shifted by every 2 units, the graph is same. So cos pi x and cos pi x plus 2 slash 4 slash 6, all these graphs are same. Okay. All these graphs are basically this red graphs only. Okay. So now what we are saying, what we forget about this x part. We are talking about cos pi x. Cos pi x between 0 and 1. Between 0 and 1, that is this part. Between 0 and we are talking about this part. Now between 2 and 3. Again, this graph, this one, and 4, 5, all even, starting with even numbers, right? These are all same. Between 2 and 3, between 2 and 3, this graph is also same as this graph. So we are talking about this part, right? Cos of pi into x plus 2, if you are taking the 2, 3 segment, then that is this part. Basically, this part and this part are same. Only thing difference is this part is multiplied between 0 and 1. So if this is multiplied with 0 and this is multiplied, at this point it is multiplied with 0. So this point is multiplied by 0. Then it increases until this point. This point is multiplied, whatever this point is multiplied with 1. So x cos pi x will look something like this. Okay. X is also slowly increasing, and we are starting with 0 into 1. Then again 0.1 into 0.9 or something. Likewise, again here 0 into 0. Right. Here 0 into something. 0 into 0.5, whatever. So this graph will look something like this. X cos pi x. Now what about this one? 2 to 3. It starts with 2, right? It starts with 2. 2 times 1. That is somewhere 2 here. Right. And it ends with 3. 3 times 1, it becomes some minus 3 here. Okay. So this line is multiplied at 2 times here. So that becomes this highest point will become 2. And multiplied with 3 times here by the time it reaches. So this graph will look something like this. Okay, this part is actually multiplied by 2 times and gradually increase and multiplied by 3 times. So this part is 2 and this part is actually minus 3. Okay, so similarly at between 4 and 5, that will be multiplied. So again this part will be multiplied with here 4 and here 5. So higher will be 4 and lower will be minus 5. Okay. So for example, I will show you the graph also. Between 2 and 3, the highest point is 2, lowest point is minus 3. Between 4 and 5, highest point is 4, the lowest point is minus 5. Okay. That is this part between 4 and 5 we have figured out, right? Between 4 and 5, between 2 and 3, between 0 and 1, this is all the same graph. Okay. So between 0 and 1, this one, the blue one is our x cos pi into x plus greatest integer function of x. Please look at the blue one. So between 0 and 1 we have figured out that is this. Between 2 and 3 we have figured out that is this. Right. Between 4 and 5 we have figured out that is this. Okay. So now we have to figure out this other set of the graphs. X cos pi into x plus 1. What is x cos pi into x plus 1? This is pi x and this is pi into x plus 1. We are talking about cos pi x and cos pi x plus 1. Cos pi x plus 1, cos pi times x plus 1 is this same graph shifted 1 unit towards the left. Right. It is the same graph, right? Pi f of x versus f of x plus 1. Right. This and this. F of x plus 1 is actually same graph shifted 1 unit towards the left. Right. What does that mean? If this green graph is shifted 1 unit towards the left, that means y-axis would be somewhere here. Instead of here, this becomes our new y-axis, and this becomes our 0, this becomes our 1, this becomes our 2, this becomes our 3, something like this. Okay. Now, here, between 1 and 2. So this is the new graph, this is 1 and 2. Again, it's the same segment. again it is the same segment. Earlier, between when the graph was originally at 0, then the segment of 0 and 1 or 2 and 3 will obviously be the same when the graph is shifted 1 unit towards the left and we are taking the next segment, right? So it's actually the same segment. The graph is shifted 1 unit towards the left and you are taking this one between again the set between 1 and 2. So that one would be same as this, right? As 0, 1 or 2 and 3. So this segment is also same basically. So now between 1 and 2, it's again we are taking the same sets. Now the same graph will actually work out now. Between 1 and 2, we are starting with the same set. The black, this all black lines are actually same. What are black lines? Black lines are cos of pi into x plus this one. Cos of pi into x plus greatest integer function of x are these black lines. These black lines. Okay. Now between 1 and 2, we want x times of this. X times of this between 1 and 2. So the blue line is actually this function x times cos of pi into x plus. Okay, so again the same thing. It is multiplied by 1 here, so that's why it is at 1, and it is multiplied at 2 here, that's why it is at minus 2. Minus 1 has gone to minus 2. Similarly, 3 1 is multiplied with 3, and here it is multiplied at 4. So 4 times minus 1 is minus 4. So basically, both these graphs, cos of pi into x plus greatest integer function of x is actually a periodic one, like this. Okay, this is actually periodic one. Now, as x goes between 1 and 2 or 2 and 3 and all, this part will get multiplied. This part is getting multiplied. Obviously, then we can see there is a break at every integer. Right, when you are approaching from the left hand side, you are getting something, and you are approaching from the right hand side, you are getting something else. So, for example, it is minus 1 and 1, it is minus 2 and 2. Right, same thing we had seen algebraically also. At 1, in between minus, when approaching from the left, it is minus 1, approaching from the right, it is 1. And when 2, when you are approaching from the left hand side, you are getting minus 2 and plus 2, approaching from the right side. It's the same thing. 2, if you are approaching from the left hand side, minus 2, right hand side, plus 2. But at 0, both left and right side, they are converging at 0. They are meeting at 0 because it is multiplication of 0 into something. Right. So, and every other integer, you can see for the negative integers also. Negative integers also, because it is multiplication with the negative, right? So that's why the graph is, whatever this part, this graph is actually inverted because you are multiplying this. This point you are multiplying with minus 1. So that point has gone here. This point you are multiplying with minus 2. That's why that point has gone to the other side. Okay, basically this graph is actually symmetric with respect to y-axis, right? It's a beautiful graph. And if you look at graphically also, we can say it is discontinuous at every integer, but continue except at 0. Okay, which we had checked algebraically also. Right, guys? Using our regular limits also we have checked, but graphically also we have checked. So the correct option is discontinuous at all of these places, minus 1, 1 and 2 except at 0. Right, guys? Hope you like this. Thank you.